Welcome to the Extreme Flight 6S electric airplane build video. In this video, we'll cover all the techniques necessary to take an Extreme Flight ARF in the 60-inch size class and prepare it from the box to high-performance aerobatic flight. While this video will primarily use a 64-inch MXS V2 aircraft to demonstrate most of the steps, we'll also use some other Extreme Flight examples, and this video is applicable to all of the airplanes in the 60-inch size class, as they all build very similarly, and is also helpful for electric airplanes in other size classes, such as 52-inch and 70-inch. This presentation is broken up into chapters to allow you to easily find the section of assembly that you wish to refer to. We'll begin the assembly sequence by working with the covering material. Your Extreme Flight ARF aircraft was expertly covered in our factory with a heat-sensitive plastic covering film called either Aura Cover or Ultra Coat, depending which region of the world you're in. This material is applied with an iron. The iron activates the heat-sensitive glue on the back of the material, and then after the material is applied to the airframe, it is shrunk again with heat. These two operations, adhering the covering material and shrinking the covering material to make it tight, happen at two different temperatures. If we refer to the technical data for Ultra Coat or Aura Cover covering material, we can see that the glue which adheres the covering material to the airframe activates at 220 degrees Fahrenheit or 104 degrees Celsius. We can also see that the shrinking of the material is activated at 300 degrees Fahrenheit or 149 degrees Celsius. When working with this covering material, we need to keep these two temperatures in mind. When your Extreme Flight aircraft was packed into its box at our factory, the covering material had just been shrunk and was perfectly smooth. However, between our factory and your workshop, your airplane has passed through many different temperatures and climate zones. The wood has expanded and contracted with temperature and humidity changes, which is a natural property of wood, and the covering may have relaxed slightly. Therefore, the first step of assembly is to go over the covering material to make sure that all the seams are perfectly adhered. For working with covering material, you can use a regular clothes iron, but a hobby sealing iron is more convenient and accurate. You can also cover the shoe of your sealing iron either with a specially made hobby cotton sock, or you can use a cotton baby sock, which we'll be using in this demonstration. With our iron set to 220 degrees Fahrenheit, the temperature at which the Aura Cover Ultra Coat glue is activated, we very lightly pass the iron over all of the seams between colors on our aircraft. We don't press down particularly hard. We only press down moderately. We allow the temperature of the iron to do the work, and we go over every seam a few times to make sure that it's well adhered. Do this for every seam between colors on your aircraft. Also, adhere down all of the margins of the covering material wherever it overlaps an edge and is trimmed away. When you remove your airframe from its kit box, or more likely after your first trip to the flying field, you may find wrinkles in your covering material. This is caused by the wood shrinking or changing shape because of changes in temperature and humidity, and is perfectly normal. Learning to remove wrinkles from aircraft covering material is a normal, necessary part of maintenance for your balsa wood aerobatic aircraft. The basic technique that we use for removing wrinkles from aura cover or ultracoat is to turn our iron up to the shrinking temperature of 300 degrees Fahrenheit, and then we use the iron as a heat source and allow the heat of the iron to cause the wrinkles to shrink. A few notes: when shrinking wrinkles out of covering material, do not press down into the covering material. Instead, very lightly glide the iron over the surface, putting no real pressure on the covering material. The reason for this is that if we press the iron down directly over a wrinkle before we shrink it, we'll turn the wrinkle into a crease and it will become permanent. A little patience and a light touch is necessary to get good results when shrinking your covering material. But if you follow these notes and you're patient and you don't press down onto the wrinkles, but instead let the iron act as a heat source and let the covering material's natural tendency to shrink at this temperature work for you, you can achieve perfect wrinkle-free results. Now, the covering material that your aircraft is covered in starts to shrink at 300 degrees Fahrenheit. The shrinking continues all the way to approximately 350 degrees Fahrenheit. So what we wish to do over the life of the airplane is to incrementally shrink at the lowest possible temperature each time. If we were to shrink the first time at 350 degrees Fahrenheit, we would be using up the shrinking ability of the covering material. Instead, start at around 300 and only make the iron hotter when you absolutely need to. If you follow these guidelines, you'll have plenty of shrink in your covering to last the life of your aircraft. Shrinking covering material with an iron is the safe way to do the job, but it can be time-consuming, and often we'll be tempted to use a faster method. A hobby heat gun is a much faster method of shrinking covering, but we don't recommend it for persons that are inexperienced working with covering material, and here's why. A hobby heat gun outputs a tremendous amount of heat energy into a small area of covering. You must keep the heat gun in motion at all times and play it very delicately over any stripes or seams between colors. If you leave the hobby heat gun pointed, even for a few seconds, at one area, this is what happens. You have differential shrinkage of the different colors, and your stripe is no longer straight. This is going to require a time-consuming repair. We see this frequently when persons who are new with covering material attempt to use only a heat gun, and this is why we recommend using an iron, particularly on all stripes and seams. To further illustrate the point, we're going to point this hobby heat gun, which does not have nearly as much output as an industrial or paint stripping heat gun, at the covering at close range to show you how quickly the damage can be done. We've often seen exactly this kind of damage on aircraft caused by relatively inexperienced builders using a heat gun for the first time. For this reason, we recommend that you use an iron for your first few shrinking jobs and leave the heat gun in your toolbox. For the next steps in the build, we'll be using thin CA glue, and we recommend that you use one of these precision applicator tips so that you can deliver precise small drops of thin CA where you want them. A helpful tip: when using thin CA to assemble your aircraft, it's quite possible to get drips and runs on your covering. To clean these up, we prefer to use acetone, a commonly available and inexpensive thinner, and a paper towel. Note that you should only use acetone in a well-ventilated area and never around open flame or sparks. The first job we'll do with our thin CA is to add a few drops to the high-strength joints on the motor box assembly, since they're exposed right now during this stage of assembly. All of these joints were glued for you at the factory, but since they're easily accessible right now, we can add a few more drops of thin CA as insurance. Now we'll move on to hinging. The control surfaces on your airframe come pre-installed with the hinges in their slots, but they aren't glued. First, remove the control surface and all of the hinges. The hinges are of the CA type, so called because they're installed with thin CA glue. The first step is to place each hinge halfway into the center of its respective slot. If you find that you have difficulty placing the hinge exactly halfway into the control surface, take a graphite pencil and make a light mark in the center of each hinge, and use this as a guide when installing the hinge halfway into the slot in the control surface as shown. Place all of the hinges halfway into the center of their respective slots. Take your time doing this. There's no need to force the hinges. Spend time to get the hinge seated accurately into place. Once all of the hinges are seated accurately in their slots, you can take your thin CA with your precision applicator tip and place one small drop of thin CA glue on one side of each of the hinges. Set this aside to cure for a few minutes. Once the hinges have cured into the aileron, give them a light tug to make sure they are affixed, and then begin to slide the aileron with its hinges into the slots on the wing. Take your time and be careful in this step. There's no need to get in a hurry or to force anything. Allow the hinges to find their way into the pre-cut slots, and they should gently slide together. Once you have the aileron slid into the wing, position it. Line up your covering stripes. Make sure that you don't have any interference anywhere, particularly between the aileron and the root of the wing. Make sure that the gap is small, and make sure that the aileron can fully flex up and down. Your gap between your wing and your aileron should be small, less than 1 millimeter. But this will still allow for full movement. Once you have your aileron in place, you can use your thin CA with precision application tip to drip 3 to 4 drops of thin CA onto each hinge location. Then you can set this aside in a safe place to cure and move on to the other wing. Repeat all of the same steps for the other wing. If you experience resistance when installing a hinge into its slot, don't force the hinge into the slot, as you can damage the hinge. Instead, take a sharp hobby knife, insert the hobby knife into the slot, and use the hobby knife to clean out the slot. Normally, one pass with the hobby knife to clean out any debris is all that it takes to allow the hinge to seat easily into its slot. Now we'll move on to installing the aileron control horns. First, find the horn in your kit with the short tab. This is for your elevator. Among the remaining 3, 1 is for your rudder. The remaining 2 are for your ailerons. To ensure good glue adhesion on your control horns, use sandpaper or an emery board or another abrasive surface to sand away the shine from the control horn tab on both sides. Make several light passes with the sandpaper. Once both sides of the control horn tab are dull and scuffed, it's ready to glue. Slide the shoulder plate onto the tab of the control horn and test fit the assembly into the aileron as shown. Make sure you can seat it all the way down into the aileron as shown. Then take medium CA glue, apply several large drops of medium CA into the slot in the aileron. Then also apply medium CA glue to both sides of the control horn tab. Then fully seat the horn into the slot. Press it down and set aside to cure. Repeat these steps for the other aileron. Next, locate the push rods in your airplane kit. 2 of the push rods will be identical in length. These 2 are for your ailerons. Here we'll zoom in on the same parts from the 60-inch Game Bird kit. 2, which are identical in length, are for the ailerons, and the other 2 are for the rudder and elevator. With this more detailed view, you can see the threads on the end of each pushrod. In this size of aircraft, both of the threads are right-hand threads, and they thread into these nylon ball links. To install the ball links onto the end of the pushrods, we can start them by hand as shown, using a righty-tighty motion, just like we would with a screw. And you can get several threads by hand, but soon they'll become very tight. As you tighten the ball links, you want to make sure you're tightening them equally, that each one is going on the same distance, and you're not getting one going all the way on while one's only on partially. Make sure that they're roughly equal in the number of threads that are still showing. But before you get too many threads, it's going to get tough and difficult to hold on to, and you'll have to resort to pliers. With a good pair of pliers, you can do this job by hand, but my favorite way to do it is to chuck the pushrod into my cordless drill. Tighten it up and use the drill to spin the pushrod onto the ball link. It goes relatively quickly and easily. Then we can loosen the chuck, open the chuck wide, insert the ball link end into the chuck, tighten it carefully, and repeat the operation for the other ball link. Again, being careful to make sure that we're tightening them a roughly equal number of turns on each side. Start with about 10 total threads into each ball link and do both pushrods. Next, we'll begin installing servos in the aircraft. But before you install any servos, we recommend that you zero each of the servos you intend to use. Hook them up to the radio system that you're going to use or to a servo tester. If using a radio system, make sure the channel that you plug them into has no sub-trim entered in on the transmitter. This way, when you plug them into that channel and you've verified their operation, once you unplug them from the radio, you can be certain that the servo is at its center or zero position, and you can proceed with your linkage installation. Once we have both pushrods assembled to roughly the same length, we can place them in position on the wing, and we can determine which direction we're going to mount our Aileron servo. The output gear of the servo is on one end of the servo, and so this quick test will verify for us which direction the Aileron servo will be installed. To install the servo, first we run the servo wire from the servo opening cutout to the root of the wing, and we install the servo in the mounting slot. Here I'm using Extreme Flight branded servo screws to install the servo in the wing. These are driven by a 2mm hex driver. Not all of the servos which are appropriate for use in the 60-inch aircraft have exactly the same case size. In the previous example, we installed the high-tech HS7245MH servos, and those are the correct size to drop into the existing openings. Among the other recommended servos for our 60-inch aircraft are the MKS HS9767. These are higher performance servos, but they do have a longer case and a longer mounting pad dimension, as shown. In order to install these longer servos, we'll need to relieve the cutouts in the wing slightly. We'll need to remove some of the plywood servo mounting opening and also a little bit of the balsa wood wing skin. To do this accurately, we use our servo as a guide, and we make a mark where we will need to remove material on the servo mount, and we also use the servo as a guide for the removal of material on the balsa wing skin. Because the amount of material to be removed is very small for these MKS servos, we're here using a sharp hobby knife to make these small cuts. First, we remove the section of the balsa wing skin necessary. And then, in a series of small shaving cuts, we remove the few millimeters of plywood servo mount which have to go to fit the MKS servos. You could also use an abrasive material, a rough emery file, or even a Dremel type motorized cutter for this work, but we prefer to use the sharp hobby knife and to go slowly and patiently to make sure we remove only the needed material. With the servo mounting hole opened up those few critical millimeters, our MKS servo drops in and is ready to mount. Now we'll begin to use the threaded fasteners or nuts and bolts included in your kit. 3 sizes of metric screws are included in your kit, M2, M3, and M4, and they're driven by these hex drivers. Aerobatic aircraft are subject to high G loading and vibration, so every threaded fastener on the airplane must be locked in place. On some of the connections on your aircraft, a nylon locking or nylock nut is used. To make it easier to see, we're going to substitute a very large example of a nylock system. As you can see, the nylock nut has a ring of plastic at one end. The other end is a metal thread. As the screw is inserted into the nylon lock nut, when the tip hits the nylon locking ring, it becomes much harder to turn. This friction locks the screw in place. Other fasteners on your aircraft, such as the screws that attach the landing gear or the brushless motor, there's no opportunity to use a nylock fastener, so we need another locking method. Loctite locking compound is the solution here, specifically the blue or removable grade. Although available in a liquid squeeze bottle, we prefer this solid stick version, which is applied to the fasteners as shown before they're inserted. Now we'll move on to assembling the aileron linkage. We'll begin by showing the completed aileron linkage for one of our 60-inch airplanes. Here the 60-inch Game Bird, which is very similar to the other models such as this Edge V2 or the 64-inch MXS. The first step to assemble the linkage is to take a piece of low-tack masking tape or painter's tape and to tape the aileron to the trailing edge of the wing panel as shown. This will hold the aileron at the zero or neutral position while we assemble the linkage. For this build, we'll be using the recommended Extreme Flight aluminum arms, and we'll be using the middle hole in the servo arm for the aileron pushrods. Note that these holes are marked that they're tapped for an M2 thread, and we'll be using the M2 fastener, which fits through the ball link hole. Insert the screw with washer and ball link into the hole and thread it into the tapped arm. Then apply another washer and nylock fastener to the screw. Note that because the servo arm is threaded for M2 thread and the nylon nut is also threaded for M2 thread, it takes a bit of care to make sure that we have a tight assembly. Examine the assembly to make sure everything is tight. Ball link to servo arm and nylock nut to servo arm, and that the washers are in place as shown. We can now install the servo arm and push rod onto the servo at a right angle as shown. When installing our servo arm center screw, because it's not a self-locking fastener, be sure to use a little bit of Loctite. The Extreme Flight servo arm also uses a safety pinch screw to hold the arm in place, which also needs a dab of Loctite. With another M2 screw and washer, attach the ball link to the aileron control horn as shown. It is at this point that you may need to adjust the length of your aileron pushrod so that it fits perfectly as shown. A washer and nylock nut are used to complete the assembly. Note that the ball link is applied on the inboard side of the aileron horn toward the fuselage. And here's the completed assembly. Note the position of washers on either side of the joint on both ends. Now we'll move on to installing the carbon fiber landing gear to the fuselage with M3 screws, washers, and Loctite. Note that the landing gears have sweep and they have a direction forward and back. For example, the Game Bird GB1 has landing gear which sweep back toward the rear of the fuselage, while the MXS, the Edge, and the Extras have landing gear that sweeps slightly forward to the front. Some of the designs use landing gear fairings between the carbon landing gear and the fuselage. These are adhered to the landing gear using one of several types of goop, shoe goo, or welder rubberized adhesives. Place a bead of rubberized adhesive on the carbon landing gear as shown. Now push the fairing into place and hold it with masking tape. Note that the fairing is only adhered to the landing gear, not to the fuselage itself. This allows it to move slightly as the landing gear absorbs shocks. Wipe away the excess adhesive and allow the fairings to cure for a few hours. Now we'll move on to main wheel install. Locate the wheel axle in the wheel as shown. Mark the location of the edge of the wheel on the axle, and then using a file or sandpaper or a Dremel tool, or as I like to use, a knife sharpening stone, make a small flat on the axle in this area. With the small knife sharpening stone, it only takes several seconds. This flat area on the axle is where the set screw for the wheel retention collar will bite into the axle. The collar is tightened with a 1.5 millimeter hex driver. Use a little bit of blue Loctite on this set screw and then tighten the set screw down to hold the wheel onto the axle, making sure that the set screw itself tightens directly onto the flattened area that you made. Once you've tightened the set screw, check to make sure that the wheel still rotates freely on the axle. Now take the wheel and axle assembly and place it inside the wheel pant as shown. Grasp the axle with needle nose pliers inside the wheel pant. The axle is retained onto the landing gear with a washer and a nylock nut. The nylock nut is tightened with a nut driver or a socket wrench, in this case a 7 millimeter size. Note, we grip the socket wrench only near its head. There's no need to apply a lot of torque to this fastener. If you apply a lot of torque, it is possible to break the axle. Use a light touch when tightening this fastener. Now, the wood screw is tightened into the wheel pant with a screwdriver. And the assembly is complete. Check for free rotation of the wheel. Now we'll move on to installing the horizontal stabilizer and elevator. Most of our designs utilize this block behind the stabilizer. Check for any pieces of tape holding it in place, remove it, and set it aside. A note of caution. This build video pertains to our latest 60-inch designs in which the horizontal stabilizer inserts from the rear of the aircraft and the elevators will be assembled onto the horizontal stabilizer before the assembly is inserted into the fuselage. This is different from some of our classic designs. Separate the elevator from the horizontal stabilizer and place each of the hinges halfway into the center of its slot in the horizontal stabilizer. When you have all the hinges placed into the horizontal stabilizer accurately, use your thin CA with a precision applicator tip to place a small drop of glue on each of the hinges. Locate the two remaining control horns from your kit. Note that they are not identical. One has a shorter tab and one a longer. The shorter tab is for the elevator, which is thinner to prevent the tab from bumping up against the covering on the top side of the elevator. Scuff the elevator horn for glue adhesion just as you did the aileron horns. Install the horn plate. Then test fit the elevator horn into the elevator horn slot to make sure there are no problems. After you've checked the fit, apply a generous amount of medium CA into the slot and to both sides of the elevator horn. Install the horn into the slot. Set aside to cure. We can now hinge the elevator onto the horizontal stabilizer. Line up the covering stripes to make sure you have both pieces the right direction, and then gently and patiently fit the hinges into their slots. If you do experience resistance, don't force the hinges together. Stop and observe to see if any of the hinges are causing any problems, and if so, remove the pieces and use a sharp hobby knife to clean out the slot. Note, we're not making a new slot. We're inserting the knife blade into the existing slot and just running the knife blade back and forth a few times to clean out any debris, sawdust, or balsa chips. After doing so, you should have an easier fit. A good fit between these parts will leave a gap of less than 1 millimeter. Equalize the space between the horizontal stabilizer and elevator on each side as shown. And when everything is properly aligned, use your thin CA with precision tip to drip 3 to 4 drops of thin CA onto each hinge. Set aside to cure. Take note of the design of your horizontal stabilizer. This notch in its leading edge interfaces with these guides in the horizontal stabilizer slot in the fuselage. This will align your horizontal stabilizer with the center line of your fuselage. Take note of the top and the bottom of the horizontal stabilizer with the horn to make sure that you're installing the horizontal stabilizer upright, and then test fit it into the fuselage. It should go all the way forward and engage the guides at the front of its slot. Once the horizontal stabilizer is in its slot, but before we apply any glue, we need to make sure that we can align it properly so that it's not twisted in any way. One easy way to do this is to insert the carbon wing spar tube into the fuselage and to measure from the carbon wing spar tube back to the hinge line of the elevator on both sides of the airplane and make sure that these two measurements are the same within a millimeter or so. Once you know how to align your horizontal stabilizer, you can use a variety of different glues to attach the stabilizer to the fuselage. You can apply white woodworker's glue before installing the stabilizer, or you can use epoxy, but here we're showing the use of CA glue. The first step is to apply several drops of thin CA to the joint between the stabilizer and the fuselage on both sides. Allow this to wick in and cure. Once this initial application of thin CA is cured, use the servo openings and the access from the rear to build a nice glue fillet of medium or thick CA inside the fuselage between the stabilizer and the fuselage. Glue on both sides and tilt the fuselage as necessary to allow the glue to run along the joint and form a nice fillet. Once the horizontal stabilizer is cured, use the adhesive of your choice. to reinstall the tail block if the design you're assembling uses it. Next, we'll move on to installing the rudder. The hinges and the control horn are handled in the same way as you did for the aileron and the elevator. Now you can slide the rudder onto the back of the fuselage just as you did the other control surfaces. Again, don't rush, don't force anything, be patient, and work the rudder into position. Check to make sure there's no interference between the rudder and the vertical stabilizer and that the rudder has free motion and a narrow gap. When everything is properly aligned, glue the rudder hinges as you did the aileron and elevator hinges. Next, we'll move to tailwheel preparation and installation. To avoid your tailwheel coming loose prematurely, we recommend that you take the following steps. First, using a 1.5 millimeter hex driver, loosen the set screw and remove the aluminum tiller bar from the tailwheel assembly. Take the spring steel axle wire and, using an abrasive such as this knife sharpening stone, make a small flat at the top of the wire where the set screw for the aluminum tiller arm is tightened. Reassemble the tailwheel assembly on the carbon bracket, replace the aluminum tiller assembly, remove the set screw, and apply Loctite. The tiller arm set screw should be tightened against the flat spot that you made on the spring steel axle wire. This will prevent the tiller arm from loosening or twisting on the tailwheel axle wire. Once the tailwheel is prepared, we can install it on the airplane. The first step to note is that the axle point on the tailwheel assembly should be in line with the rudder hinge line. Once you've found this point, use a hobby knife to mark the location of the two holes in the tailwheel bracket. And mark the location of the center of the slot in the aluminum tailwheel tiller into the rudder. Open the holes with your knife point slightly, as shown. Then place a drop of thin CA into each of these holes. The tailwheel is retained onto the fuselage with two wood screws featuring washer-style flat heads, and the tiller is retained into the rudder with this screw, which does not have a washer head. Drive the two wood screws with the flat washer-style heads into the fuselage to mount the tailwheel permanently. Then drive the tiller locating screw into the rudder, but don't tighten it fully. It's important that the tiller floats on this screw and that the screw can move back and forth within the tiller slot. This floating action is important to prevent the tailwheel from imposing any additional load on the rudder servo. Now we'll move on to installing the elevator linkage. Before we begin, here are some photographs of representative linkages from the 60-inch Extra NG. the 60-inch Edge 540T V2, the 64-inch MXS V2, and the 60-inch Gamebird GB1. Note that on the elevator linkage installation, we use the outermost hole on the 1.25-inch Extreme Flight servo arm. For this build, we're using the Extreme Flight branded 28-gauge, 24-inch servo extension for our tail servos. Connect these extensions to the servo wire, light wire to light wire, black wire to black wire, with the red in the center, and then secure them with an Extreme Flight servo clip to prevent them coming loose in flight. Feed the servo extension wire through the servo opening and into the fuselage. The wire will need to be brought forward into the receiver area. Work the wire forward through the fuselage. Note that the Extreme Flight designs provide wire holders integrated into the fuselage construction at several points. These wire holders are useful to keep the extension wires from moving around in the fuselage during hygiene maneuvers. Although all of the fuselage designs are slightly different, they all include wire holders and pass-throughs. Examine your fuselage to find the logical wire routing. Then you can move on to mounting your elevator servo, just as you mounted your Aileron servo. Here we are again using the Extreme Flight branded servo screws. Note that if you're using a servo with a larger case size, such as the MKS, the procedure to open the slot is the same for the elevator servo as it was for the Aileron servo. Measure carefully, take it slow, and only remove as much material as is absolutely necessary. Next, we'll move on to installing the elevator linkage. Just like the aileron, the first step is to apply a piece of masking tape of the low-tack or painter's variety to the control surface, in this case the forward or balance area of the elevator and the horizontal stabilizer, to keep the elevator in the neutral or zero position while the linkage is being installed. Using the same types of fasteners and the same techniques that you did for the aileron linkage, install the elevator linkage onto the elevator servo arm, but this time note that we're using the outermost hole in the Extreme Flight 1.25-inch servo arm. Place the servo arm onto the servo output shaft. Apply the servo center screw with Loctite. And also the pinch bolt with Loctite. Now, adjust the length of the elevator pushrod as necessary and attach the elevator pushrod to the elevator horn using the same fasteners that you did to attach the aileron pushrods to their horns. Next, we'll move on to Rudder servo linkage installation. We begin with some images of completed linkages on the Extra NG, the Edge V2, the MXS V2, and the Gamebird. Note that it's a matter of personal preference whether you use the outermost or the middle hole in the rudder linkage. We recommend that you start in the middle hole, and if you find that you desire more rudder throw than you're able to achieve for certain maneuvers, move to the outer hole. The steps for the assembly of the rudder servo and the rudder servo linkage are the same as the steps you've already undertaken for the aileron and the elevator servos and their linkages, so we'll move over these quickly. This completes the last of your control linkages. Now we'll move on to the power system. The X-Power 22cc motor is the recommended power plant for your airframe. It includes these M3 screws, which are used to hold the prop mount onto the front of the motor, and also these short countersunk Phillips screws, which are used to attach the mount to the back of the motor. Apply Loctite to all of the screws used on the motor. Install the mount on the back of the motor, taking note that the countersunk screws fit down into the holes in the mount, giving a flush or smooth rear surface to the motor mount. When attaching the prop mount to the front of the motor, note that it fits precisely onto the machined features on the front of the motor. As you're tightening down these screws, make sure that the prop mount is seated firmly and accurately onto the front of the motor. There should be no gap here at this joint. Note that in the event of a crash, both the prop mount and the motor mount are replaceable using these screws and are available from Extreme Flight. The prop washer and prop nut thread onto the front of the motor as shown. Now we'll move on to mounting the motor and prop on your aircraft, but before we do, we'll make a note. If you examine the motor mounting plate or firewall on the front of your aircraft, you'll notice that it's not mounted perfectly straight to the long axis of the airplane. Instead, the firewall is angled to the right between 2 and 3 degrees depending on design, and this is intended. This corrects for the gyroscopic and aerodynamic forces applied to the airplane by the spinning prop. Install the canopy hatch onto your airplane and then temporarily attach the motor to the firewall with a couple of the M4 mounting screws provided. Then install the cowl. The cowl is attached to the fuselage with 4 M3 screws which thread into pre-installed M3 blind nuts in the fuselage. It might be necessary to clean the paint out from the hole slightly with your hobby knife. Install the 4 cowl screws, keeping in mind that this is temporary, just to check fit. Check the fit of the spinner to the front of the cowl. These components can't touch or rub in flight, so what we would ideally like to have is a gap of approximately 2 to 3 millimeters between the back of the spinner and the front of the cowl. In this case, the motor will have to move forward. Spacers are included in your kit for this purpose. Once the correct motor spacers have been determined, place the motor spacers between the motor and the firewall, and then install the motor permanently using washers and Loctite on the M4 mounting screws. Next, we'll move on to the ESC. Here we're using the Extreme Flight Airboss 80 ESC, which plugs directly into the X-Power 22 motor with no modifications. It's a good idea at this point to hook up the ESC to your receiver and battery, activate the system, make sure everything is working, and verify the direction of rotation of the system. The motor should spin in this direction, counterclockwise when viewed from the front. If the motor were to spin in the wrong direction, swapping any 2 of the ESC to motor connections reverses the direction of rotation. Securely mount the ESC to the provided ESC mounting pad on the bottom of the motor box using either nylon zip ties or Velcro straps. Bring the ESC wiring into the fuselage. Note that the Airbus 80 includes this on-off switch as part of its wiring. If you choose not to use the on-off switch, we recommend that you use a nylon zip tie to tie the on-off switch permanently in the on position as shown. And then securely tie the on-off switch with the rest of the wiring into the fuselage so that it can't move around under high G load. Depending on cooling requirements, your kit may include cooling deflectors or baffles to be mounted to the cowl or motor box. In the case of this plastic style of cooling deflector, cut them loose using a pair of scissors along the lines that are molded in. Although several different types of adhesive will work for affixing this type of deflector to a cowl, we prefer a rubberized adhesive such as a goop type adhesive or a thick CA. Once you've applied a liberal amount of glue to the deflector, place it in position on the back side of the cowl cooling opening. As you can see, the deflector acts to turn the air coming in the front of the cowl toward the electric motor. Set the cowl aside and allow the glue to cure. Some of the other designs, such as the 64-inch MXS V2, use wooden air deflectors. In the case of the MXS V2, the parts kit is made of balsa wood and looks like this. It acts to turn the air which comes in the scale MXS cowl vent toward the electric motor. The parts for the kit are marked left and right, the L going on this side. Assemble the parts kit with medium or thick CA glue as shown. Each of the deflectors fits on the side of the motor box that it's marked for. Once in place, you can complete the installation of the deflector with medium or thick CA glue. Repeat the process for the other side. Once both deflectors are glued in place, test fit the cowl over the deflectors to see if there's any interference. In this case, there is slight interference preventing the cowl from completely going on. Trim as necessary with scissors, a knife, or sandpaper to get a good fit between the baffle and the interior of the cowl. Next, we'll permanently install the cowl with its fasteners. First, install the canopy hatch and latch it down. The cowl hardware included in your kit is 3mm fasteners with these bright washers. If you use this hardware, be sure to use Loctite. However, in this build, we'll be using the optional Extreme Flight anodized aluminum washers. These washers have a ring slot machined into their backside to accept an included O-ring, which acts as the thread locking device for this joint. Mount your receiver to the receiver tray behind the wing tube in your fuselage. You can use a variety of different methods for this mounting: double-sided tape, self-adhesive Velcro, Velcro straps, or nylon zip ties. We recommend that you use two methods. In this case, we've used double-sided tape between the receiver and the tray and a nylon zip tie for extra security. Install the wings onto the aircraft by sliding each wing panel onto the carbon fiber wing tube and bringing the Aileron Servo wire through this port in the side of the fuselage. As you slide the wing all the way in, note that these carbon alignment pins will enter the fuselage at these points, and once the wing is tightly up against the side of the fuselage, you can close the wing latch and it will lock in place. A note about servo wiring. Because you remove the wings and reinstall them every time you take the aircraft to the field, it's important that you have a strategy for easily plugging and unplugging the Aileron servo wires from their extensions. In this MXS, we've chosen to glue 3-inch extreme flight extensions into the tray so that we can easily plug the aileron wires into them. Now we can move on to setting up control surfaces, starting with the elevator. First, check to make sure the surface is moving in the right direction and reverse it if not. Then use your sub-trim to bring the elevator perfectly in line with the horizontal stabilizer. Now attach the throw meter or gauge of your choice and zero it. Now we can set our high and low rate elevator throw. There are a few considerations when setting up your elevator throw. First, you'll need a low rate elevator, and this should be a gentle and predictable setting of no more than 8 to 10 degrees up and 8 to 10 degrees down, using 15 to 20% exponential. This is a very gentle setting for precision maneuvers and especially for smooth landings. For flying 3D maneuvers, your high rate elevator should be at least 45 degrees up and 45 degrees down. This is necessary to make sure that when you pull full elevator to stall the aircraft to enter 3D maneuvers, that both wing halves stall at the same time. An exponential setting of 60 to 65% will make this elevator rate smooth and easy to fly. If you want to extract maximum tumbling performance for XA maneuvers from the aircraft, it can benefit from an elevator throw in excess of 60 degrees, and the mechanical setup we've outlined in this video will allow you to achieve that. However, this amount of elevator throw can make it very difficult to fly 3D maneuvers such as the Harrier smoothly. If your radio has triple rates, you might consider putting this tumbling rate on your third rate, the 3D rate in the middle setting, and the low rate at the low rate position. If your radio only has high and low rates, we recommend that you start with the low and 3D rates. Moving on to the rudder, begin by checking the direction of throw and reversing the rudder if necessary. Then sub-trim to align the rudder with the vertical stabilizer. Using your throw meter, set your rudder low and high throws and exponentials. For a low rate rudder setting, we recommend you begin with 20 degrees left and 20 degrees right with 40 to 45% exponential. For a high rate rudder setting, we recommend you begin with 45 to 50 degrees and 80 to 90% exponential. Note that if you do experiment with higher rudder throws, make sure the rudder and elevator can never contact each other at any point in either of their travels. Moving on to the ailerons, start the same way by checking for proper direction of movement on both ailerons. But make a special note here. Reversed ailerons are one of the most common causes of crashes for newly assembled model airplanes. Double check to make sure your ailerons are moving in the correct direction. For a starting aileron low rate, we recommend 15 to 20 degrees up and 15 to 20 degrees down with 40 to 45% exponential. For a beginning high rate aileron, we recommend starting with 38 to 40 degrees up and 38 to 40 degrees down, along with 70 to 75% exponential to smooth things out. Note that this will give you a very fast roll rate at high speed. However, high rate aileron is a personal and subjective thing, and for many pilots will come down to the desired hairier roll rate that they have when flying 3D maneuvers. We recommend, once you're used to the aircraft, experimenting with both more and less high rate aileron to find your sweet spot. Now we'll install the prop and spinner on the airplane. First step, note that the Extreme Flight spinner has adapter rings so it can fit multiple shaft sizes. Find the right shaft adapter and install it on the shaft of your X-Power motor. Then take the back plate of the spinner and notice that there's a slot on the front side. This slot accepts the ridge on the back of the plastic spinner cone as shown. The back side of the plate is smooth and has no slot. Install this smooth side up against the cowl. Next, the prop. Make sure the prop is facing the correct direction and install it perpendicular to these two holes. Next, the washer and the prop nut. Before fully tightening the nut, take the spinner cone, line it up with the holes in the spinner backplate, and make sure there is sufficient clearance around the blades. Next, we'll tighten the prop nut. Note that if you're unsure how tightly to tighten the nut, don't use a wrench, use a pair of pliers. It may cause a bit of wear on the corners of the prop nut, but you won't be able to over-tighten the nut so badly that you damage the shaft. Now with your 2.5mm hex tool, tighten the M3 screws which hold the spinner cone onto the back plate. Next, we'll move on to balancing the aircraft, or setting its center of gravity. The center of gravity, often abbreviated CG, also called balance point, is that point which, if we support the aircraft as shown in the diagram, the aircraft will balance level. The location of the center of gravity fore and aft on the airplane is among the most important tuning points for the aircraft. If the center of gravity is moved forward, that means that weight is moved forward in the airplane, typically by shifting the li-poly battery, the airplane will become more stable, smoother, and easier to fly. If, on the other hand, the center of gravity or balance point is moved back, the aircraft will become more responsive and more maneuverable, but more difficult to fly and less smooth. For this reason, center of gravity location is really a matter of personal preference and may not be exactly the same for any two pilots. Typically, a more experienced pilot can make use of a more rearward center of gravity, while a beginning pilot should probably stay at the forward edge of the center of gravity range. In this section of the video, we'll show you our basic and simple two-step process for setting the CG of your aircraft. The first step is a rough setting of the balance in your workshop to get you ready for your maiden flight. The second step is conducted during test flights at your field to set the balance much more finely. Here are recommended center of gravity range values for the latest generation 6S aircraft from Extreme Flight. Note that the MXS V2, the Extra NG, and the Game Bird, being similar size with similar wings, are all very similar in their CG value. The Edge 540 V2, with its uniquely shaped wing, has a different set of values. To make this process simple and easy, we recommend that you take a ruler and a marker, and you mark the CG locations directly on the bottom of your aircraft wing. Here we're marking the 4.5-inch forward location and the 5.25-inch rear location on the bottom of this Extra NG set of wings. Then take a drop of thick CA and place it at these CG locations directly on the bottom of the wing. Apply some accelerator to dry the glue in place instantly. These drops of glue now form bumps that you'll easily be able to feel with your fingertips when you're supporting the aircraft to balance it. Here we lift the aircraft with our fingertips on the forward CG bump, and it hangs level with the battery in a forward location. Here's the MXS being supported on its forward CG bumps with the appropriate battery location for it to hang level. And here's the appropriate battery location for it to hang level by the rearmost bumps. This fingertip balancing method is perfect for setting the rough CG in your workshop and finding a good battery location so that the airplane balances on the forward edge of its allowable range. This will be a good, safe CG location for your maiden flight. Once you've determined what your starting battery position will be to give you a safe forward CG for your maiden flight, then you can arrange your battery hold downs. First, we use self-adhesive Velcro on the battery tray and the battery itself. This keeps the battery from sliding forward and aft on the battery tray. We also use 1 or 2 battery hold down straps which go completely around the battery and hold it down tightly to the tray. This Velcro on the battery tray and the straps which go around the battery work together. Neither can be omitted. Now we're ready to move to the second phase of setting our center of gravity, which is the fine adjustment that we do through flight testing. The first step is to trim our aircraft so that it can fly hands off without any attention from the pilot across the field straight and level. Spend some time getting the aircraft perfectly trimmed so that it will proceed on a straight heading across the field straight and level with no attention from you. Next, fly the aircraft level at about 2/3 throttle. Pull up to a 45-degree climb and roll inverted. Take your hands off the sticks and allow the aircraft to fly along its natural path for the next several seconds. The path the aircraft takes with your hands off the sticks will tell you what your current CG location is. A nose-heavy aircraft will pull sharply toward the ground. A tail-heavy airplane will balloon up into an inverted climb. What we're ideally looking for is the green path, an aircraft that continues along its path for a period of time and then gently begins to arc toward the ground. If you don't get the result that you want, land, move your battery, and retest. But remember, you have to go through the trimming process each time to make sure your airplane is perfectly trimmed so it flies across the field straight and level, hands off. Then you can repeat the 45-degree inverted climb test. To install the decals included in your kit, first cut around them with scissors to release them from the sheet. We prefer to do a wet installation of decals, which means we mist the application area on the airplane with either water with a small amount of dish soap in it, or preferably rapid tack application fluid. Only a light misting is required. Then remove the decal from the backing paper. Place the decal in position. Begin to work the liquid out from under the decal, starting in the center. Work toward the outside edges of the decal, working the liquid out from under the sheet. Then switch to a squeegee, old credit card, old motel room key card, or some other resilient piece of plastic. Work the remaining liquid out from under the decal. Finish with a cloth or paper towel, working the last remaining droplets of water out from under the edges of the decal. When all the liquid is worked out from underneath, the decal will be fully adhered. Allow it to dry for a time and the installation will be permanent. Most of our kits include SFGs, or side force generators, which are connected to the wing tips with thumb screws. Also included in your kit is a clear plastic spacer to space the SFG out from the wingtip and prevent aileron interference. SFGs have a few different effects upon your airplane's flight characteristics. First of all, they increase rudder authority, and they can allow you to fly more aggressive rudder maneuvers in some types of flight. You should try flying with and without the SFGs to check this effect. Secondly, they also affect the roll response and stability of the airplane. Many pilots attempting 3D maneuvers such as the Harrier for the first time may find that SFGs make the maneuver much easier. They're easily removable, so you should try back-to-back flights with and without the SFGs to determine whether they suit your flying style. The 64-inch MXS is somewhat different, as it includes these scale racing wingtips. They can be installed either with the SFGs or without, and they also have an effect on the flight characteristics of the airplane. You should try flights without anything on the wingtips, with the SFGs only, and with the SFGs and the wingtips, to determine which of these configurations best suits your flying style. Rudder authority, roll response, and stability will be slightly different for each of these configurations. Together, the SFGs and wingtips make the MXS V2 very forgiving on its roll axis and may be a great aid to those learning 3D maneuvers for the first time. Definitely try all the available configurations before choosing the one that suits you best. After the maiden flight of your new aerobatic airplane, check all of the nuts and bolts, linkages, hardware, and horns and make sure that everything is remaining tight and secure. Get into the habit of checking over the hardware on your airplane after every few flights. For maintenance of the exterior surface finish, we prefer to use a spray wax product, buffed with a soft, clean cloth. If any wrinkles develop in your airplane, Use your iron with the soft cotton sock to remove them. We hope you enjoy many, many flights with your Extreme Flight aerobatic airplane. Please check back frequently to our extremeflightrc.com website for new releases or for any repair parts you might need. Thanks for watching this video, and happy flying.